I hope you can all hear us because we check the messages. If everything is okay, we start with Alexis, and we're really sorry about a little problem. Alexi, the mic is for you.
Okay, so good evening again. Thank you very much for inviting me in this series of lectures. I will be talking about a different kind of archaeology today. I don't know if most of you or some of you are familiar with this ensemble of archaeological archive. So we're talking about the all those stuff that we were trying to figure out about the maritime culture and all these things that are found under the water. We will try and access this archaeological archive through the endeavors of maritime archaeology. So in the beginning, I will make a short intro about the subdiscipline and mostly the scope of our investigations underwater, and then we will move to more detailed matters about the methodology and technology used in order to map this archaeological archive. So when we talk about the underwater cultural heritage capital, most of the times, and the first thing that comes to mind to most people is shipwrecks. Well, and rightly so, because shipwrecks comprise, if not the majority, the most famous part of underwater cultural heritage, and they are taking of the resources. There are most of the resources nowadays about underwater archaeology are used in order to investigate and try to create interpretations about shipwrecks and this particular category of finds. Uh, Unfortunately, the image that you see now, a mostly intact ship, is not what shipwrecks are all about. Most of the times, especially when we're talking about the Med, or we're talking back in time, further back in time, shipwrecks do not have this typical image of a boat that has sunk. Rather, they are mostly visible through their cargo. And this is something that is the uh, the typical image in the Mediterranean. Uh, when we talk about the North Sea and the Baltic Sea and other parts of the world, maybe we can find some more intact ships that we will see, as we will see later on in this presentation. But especially in Greece, we're talking mostly, when we're talking about ancient shipwrecks, we're talking about their cargo. And the most typical cargo is amphorae. So those jugs, those ceramic vessels that were used as the containers of precious goods in the uh, classical antiquity times. And nowadays, this image that you see in front of you, this picture is the most typical form of maritime archaeological site, a shipwreck site in the Med. However, there were also other types of cargo, even though the majority of sites are ceramic-based find sites. There were other types of cargo, like this pile of stones. Imagine that everything that was built with material that was taken out of quarries, like those stone blocks, was in antiquity was mostly carried with ships. Even today, if something is very heavy, it's much easier to travel through water. So that's another type of maritime archaeological sites that we find in this category of shipwreck sites. Nowadays, archaeology is not only about ancient times, so there is an increase in the interest, especially in the med in trying to figure out about shipwreck sites that belong to modern times. This is something, of course, that has been happening around the world, like in the North America and Northern Europe for a long time now. But it's something that is gaining in the classical archaeology context as well, in countries like Greece and Italy and Spain. And of course, there's another type of modern shipwrecks that are not actually ships. There are aircrafts. There are modern sites that belong mostly to World War II, and they are a very interesting category because they are something. They're ensembles that intrigue the general public. It's something that is quite familiar. They're quite familiar with, and they really try to get into the story of those sites. Anyway, this is this large category of underwater cultural heritage sites is what shipwrecks delivered to us. And the next big thing is submerged landscapes. So we have a category of shipwrecks, and we have a vast archaeological archive that belongs to this category. We're talking about shifting morphology. So the coastline is rapidly changing through time, either because of the sea level change due to the ice melting, or because of eustatic changes when the land is actually uprising. So what we end up with is mostly sites that were used to be terrestrial and nowadays are underwater. And they're very, very interesting because they belong to maritime cultural contexts. And nowadays they're only accessible through the use of underwater technologies. And they're scattered around the world on various environments, and we try to understand them. So we have terrestrial sites that are now underwater, and we have harbor installations that were built on this on the coastline. So something that belongs both in the air or on land and both underwater. But nowadays, again, because of this sea level change, the rising of the sea level is now underwater. So again, if you want to access this archive, you have to work underwater. And this is where nature plays tricks. So we have the exact opposite. We have a movement in the exact opposite direction when, due to earthquakes or other kinds of geological movements, there are nautical sites like this harbor that you can see in the photograph that are now on land, because this is, for example, in Crete, and we know that Crete, the western part of Crete was rose up sometime in the 4th century AD. So we ended up with a harbor away from the sea. And this is another example of a nautical site that is nowadays terrestrial. So it's the harbor of Theodosius in Constantinople. Because of the alluvial deposits, nowadays is part of land, but we know that this was the harbor basin in the 5th and 6th century AD until those finds, those times. So there are the shipwrecks, we have submerged landscapes, and we have another category of isolated underwater finds. For example, you find an anchor that was obviously attached to a ship. At some point, this anchor was stuck on the seabed, and it wasn't easy for them to retrieve it, so they just cut the rope. And now nowadays we find this isolated find, but we don't have the context. And the same goes with a lot of artwork that artifacts that were found underwater. Most of the times, the majority of those ended up in the hands of archaeologists from fishermen and other workers of the sea. They caught this. They used to catch this kind of finds in their nets, and they just delivered them to the archaeological community. But again, we don't have any context for those finds. We can only study them typologically, morphologically, and try and find to give interpretations through the study of those specific category. And lastly, although the most of underwater research, especially in countries like Greece, is carried out in the sea due to the extended nautical tradition and a maritime commitment that the people of various countries have with the sea. However, there is a pretty interesting archaeological archive that is set in inland waters like lakes and rivers. I must admit that in Greece, we are trying to kindle this kind of investigation at this period because it hasn't caught up yet. But in other countries like in Switzerland, in Austria, and Germany, like in Central Europe, this and the UK, this is something that has been happening for a long time now. So this is more or less the extent of the archaeological archive that we're trying to access and trying to investigate in most cases. A few words about maritime archaeology again as a subdiscipline, just in order to give you some context about what we're trying to do. So the trying to retrieve artifacts from the water is something that is quite old. There are people that say, well, the first shipwreck mostly happened as soon as people tried to travel through water. So the first thing that was retrieved from the water was probably this unfortunate event, something that fell in the sea and people tried to retrieve it. Although that's obviously not archaeology, it was salvage operations. We know that there were divers from antiquity that were actually getting paid to get precious cargo or artifacts. And this is something that is also mentioned in the Lex Rhodia, a legal text that goes back to classical antiquity. But until the recent, the modern times, people did not have the tools to work underwater. So diving was solely something that was in the imagination of various people like Aristotle and artists and literatures. So there are all those stories about, for example, Alexander the Great going down with a glass bell in order to inspect the sea bottom and stuff like that. But the truth is that underwater research was limited to human breath. As long as you could hold your breath, that was the time limit that you have to explore the sea bottom. And there was a very long tradition, obviously, of divers, of skin divers, that could work underwater to retrieve stuff. But what actually changed underwater research was the diving suit that was introduced sometime in the 19th century, and it allowed people to stay longer durations underwater and actually work. And the first archaeological endeavors started in the 19th century, like this is a picture from underwater research in the UK. And what most of us believe to be like the cradle of underwater archaeology is the Antikythera shipwreck that was found in the 1900s, and it was one of the first major underwater archaeological expeditions that happened worldwide, and actually delivered a lot of interesting artifacts that until today continue to be exhibited in the National Museum in Athens, the National Archaeological Museum in Athens. So everything changed in the 1950s with Juan Cousteau and Emile Gagnan, his partner. They introduced the aqualung, so the self-contained underwater breathing apparatus, the scuba diving. Now people didn't have to wear the heavy diving suit, and they didn't have to uh, be connected to the boat. They were self-sufficient, and this actually gave the chance to archaeologists to start doing their work underwater. So we have some of the first pioneering work in Cape Caledonia by archaeologist George Bass and his collaborators, they were actually taking archaeology and introducing it into the underwater environment. There were many expeditions that and many projects that started in the 70s, like the Kyrenia shipwreck, and we started getting stuff out of the water in order to be able to study them and interpret them. This is the example of the Kyrenia, but of course we have the examples of Vasa the Mary Rose in Northern Europe that were until today they're very very interesting, and someone can visit the relevant museums and see how they were preserved in the Baltic and the North Sea respectively. In the 2000s, modern technology was introduced, and we were able to extend the limit, and we were able to go deeper and look for shipwrecks where humans cannot actually go and research. So we use robotic systems, remotely operated vehicles to go there. But at the same time, diving technology is still evolving. So humans can now go deeper and stay longer and use very specific tools to do their job and access the sites, document the sites, and produce interpretations of the finds and their context. And nowadays, as I said in the beginning, we're not, as an archaeological community, we're not just interested in the further past, like just for classical antiquity in the Middle Ages. Nowadays, archaeology is extended to modern times as well, and it reaches actually the Second World War II, the Second World War, and beyond that. And another expansion that actually happens and derived mostly from theoretical interpretations is the fact that we're not just interested in the material culture, but we try to get all this together, the study of material culture, and get it together with intangible cultural heritage in order to, again, to understand what's going on. This happens along with a lot of data that are also taken from literary sources. Maps, iconography provides a lot of data that help us interpret the finds and give some context to the archaeological sites that we're investigating. But at the end of the day, it all comes down to primary data survey in trying to extract the data from the underwater environment. So things are not, as you understand, things are not easy because we're working in a hostile environment and there are a lot of distractions that get in the way, a lot of impediments. But there is still survey that's being carried out in order to map and find new sites. There's excavation that is being done underwater under, of course, certain different protocols. But again, it's still excavation, so it follows the basic archaeological procedure. And all of this is going out in an academic way in order for us to share the data that's been extracted. We have experimental archaeology in trying to figure out if the theories that come out through the study of the material culture are actually valid. And sometimes it works, sometimes it's not very conclusive. And in the end, there is also ethnography because there is a very long nautical tradition. If you think about it in the pre-industrial times, the way that ships are being built and the way that sailors and people that have to do with the sea are communicating with the maritime environment hasn't changed a bit. It was the industrialization that, and of course nowadays we have computers, and we're talking about a different way of maritime travel. But up until that, shipwrights and captains and sailors were actually using the same techniques in order to master the maritime environment. And now we come to the way that mapping and new technologies is introduced nowadays, and not just in cultural heritage in general, but especially into underwater cultural heritage. So when we're talking about underwater research, I don't have to explain to you, I guess, why this is important for archaeology. Archaeology is all about special relations. So you need to know where things are being found and what is the relationship between them, both in the X, Y, and Z axis. But uh, when we're talking about underwater archaeology, is a little bit more. Um, it is extremely valuable because we're talking about environments and sites that cannot be visited limitlessly. So you have a limited amount of time that you can spend on the underwater site, and that means that if you have good documentation, a good mapping of the actual site, you can still work outside of the water, and you can produce the most effective plan for underwater research when you're actually in the underwater environment. In order to do that, in order to access the sites and to in order to spot the sites, put them on a map, and see what we can do with them next, we use satellite photos, which are especially in the clear waters of the Med and other parts of the world, are very, very revealing. You can actually spot underwater structures through satellite photos. And of course, we use aerial photography. Nowadays, we have drones and UAV, so you can actually understand the archaeological context, the archaeological site, by looking at it from above. Imagine that this is, for example, the one of the moles in the Lehen Harbor, and this is what you can actually understand looking from above, and this is what you can understand looking below. So it is obvious that you have a clear view using the aerial photograph and trying to understand on a macroscopic level the structure, and of course then you access the structure underwater to get more details and use on a micro level. And it is when it comes to documentation, again, I don't need to emphasize the importance of documentation in archaeological research. I will just remind you that when you work underwater, you're in a hostile environment. Things are not as easy as they would be on a land side. So, of course, you have the classical drawing scheme, so you can have someone draw something, but this takes time, and it's much easier to capture uh, pictures through photographs and video in order to have a very good documentation, both of the site itself, but also of the procedures that are taking place throughout archaeological research. And beyond that, we have different, a variety of mapping technologies that actually help us to deliver different outcomes. So we use both sound and image underwater. Sound is much is efficient because it travels very far and very fast underwater. So the acoustic technologies like the sonars are very good at getting pictures of the seabed and what lies on the seabed in remote locations for remote sensing, and in situations that the visibility is not very good because you have a lot of water between the instrument and the actual thing that you're trying to document. So when it comes to remote sensing, there are different technologies. We can discuss about them if you like afterwards. The most traditional one used to be side-scan sonar, but nowadays, the one that is mostly used is the multi-beam sonar. Imagine an array of beams like sounds that are sent in the form of beams and are being reflected on the seabed and captured back by the instrument, the multibeam, and there are these data are extracted and put in the very sophisticated software, and you can have real-time a 3D depiction of what's being scanned underwater. And this is what a shipwreck looks like in on the screen of a multi-beam scan. So you have this 3D extrusion of the seabed, and then you go back and try to see if it's diveable. You go and check it out to see if it is actually a shipwreck of, or if it's not, you just send an ROV or something that can reach the depths and figure out if this is what you were looking for. Nowadays, we have new technologies, and this is like an evolution with the laser scanner. So we use light in order to have this kind of scanning technologies. Again, if you want details about this procedure, we can talk about it afterwards. But so what the laser scanner brings is more detail, or supposedly more detail. We're trying to figure out a way to use one of those structural light scanners with the Aristotle University of Thessaloniki now, and hopefully in the next year we will have some results scanning archaeological sites that I will be very happy to share with you. But let's see how that goes. But what most all of those technologies that I've just mentioned are quite expensive, quite sophisticated. What most people do in underwater research is use photogrammetry. And so photogrammetry, I'm guessing that I'm talking to an audience that is familiar with the term, is something that, again, and more or less, you take a lot of photographs and you produce structure for motion. So you use the camera, you move around, take a lot of photographs, and then you feed them into the computer, and you get a 3D model that is accurate enough for you to take measurements on. So this is what happens in most archaeological projects nowadays, underwater, I mean. And the results, obviously, you have photo mosaics, so a lot of photographs stitched together in order to get a large image that includes all of the area that interests you. And the next phase is to produce a 3D model so that you can spin it around and study the site on your computer screen. Again, I'm saying this is very important for underwater archaeology because of the limited time that a diver has to be on the site. There are some limitations to what the human body can restrain, can actually handle when it's underwater. So that's why I'm always talking about limits. You cannot be in the water forever, especially if you go deep. Thus, it is really important to have a very good documentation so that you can maximize the efficiency of your work when you are in the water. And that is also something that can be used for shipwrecks. It can be used for submerged landscape structures and the artifacts themselves. We try not to retrieve artifacts from the seabed following the priority of UNESCO's directive for in situ preservation, but of course this is just something that we try to do. It's not always possible, so you need to extract finds from the actual site, but if possible, we try to 3D model stuff underwater in order to have time and study them without taking them out of the water, because there are some conservation issues that need to be handled if you do that. When photogrammetry is something that can be carried out by a diver, but when we're talking about sites that are not diveable because they're very deep, on toxic waters, or in places that anyway, a human cannot actually access. There are robotic technologies like this ROV that can carry the camera for you and take a lot of pictures. You handle this from a lot of computer screens, and you try to access the artifacts and the sites. And using the ROV, again, you can produce photo mosaics, 2D images of the site itself, and but also you can have a 3D model or representation of what's out there, again, without having to dive the site, just using the vehicle. This is, for example, a very nice 3D model that was produced from a shipwreck that was found in the Black Sea a few years back. And because of the toxic environment of the Black Sea, the wood was very well preserved, and we have a very good representation of. They found a few shipwrecks that were very, very well preserved and gave us a lot of insight about the way that ships were built from the 5th century BC up to the Middle Ages. And lastly, one of the most, nowadays is not state of the art. It used to be, but now it's quite common there, but still very, very expensive. So not a lot of people can do that. There are the automated underwater vehicles that use autonomously. So you set up the place that you want to scan, you send the AUV, it goes there, it just scans the area and gets back and delivers the data to you. Again, if you have questions about how all that works, we can discuss this in the end of the lecture. So there are a lot of ways to create 3D generated to generate 3D models and have spatial data and put them. Of course, you have to organize all of those data. That's why nowadays GIS is something that is also being used in the managing of data deriving from underwater environments. And if you're lucky enough, you have the equipment to work with the GIS also underwater. But this is not something that happens. And as you understand, the more sophisticated the technology, the more expensive it is, and the less often is being used in archaeological projects. But again, having those 3D data from whether they are from ROVs or divers or acoustic or laser scanners or photogrammetry. So you have those data, and this is actually something that can be used not just to understand the site itself, but also to understand the finds. So you can use those data in order to produce experimental digital models and try to figure out if they are corroborating or they are rejecting your theories about the site and its finds. So all of this large category of technology is being used not just for research, not just in order to extrude data to understand the site, but also in many cases to plan strategies about its protection. It is quite obvious that all of those sites, I mean, let me rephrase that. It's not obvious to everybody, but it's definitely true that all of those sites are in danger, even if they're made out of metal, even if they're very deep. They still need to be very well documented because they are losing their mass every day due to various threats, whether natural or anthropocentric. So in order to manage a site, you get a lot of documentation through these technologies, and you can, when you have a very well documented and mapped site, you can talk about its protection. You can get involvement from the local community and make them understand how to handle the sites. Of course, it helps in project management and logistics. And something that is very, very important, when you have a continuous flow of data through those mapping techniques, this means that you have the evolution of 3D space in time. So you have a fourth-dimensional documentation, and this actually helps very much to understand the site formation processes and see also the decay and the different environmental conditions that actually affect the site itself. And of course, if you get all of those data and put them again into a GIS and organize them in a way, you can better understand not just the specific site, but a whole wider area that comprises various sites from different periods and different materials and different interpretational modules. And if you put them all together using various algorithmic methodologies, you can extract, like ecosystem services, for example, you can extract interesting results that can provide, again, insight in terms of management and strategy concerning the protection of the site. So we have research, we have protection, and lastly, we have the creation of interaction and communication between the sites and the general public and a wider audience. So in terms of interaction, having the opportunity to document and map the sites means that we have enough data to provide access for people that are not divers or not archaeologists, do not have the opportunity to visit the sites themselves. So we can make virtual environments. There is a tendency nowadays to create a lot of underwater virtual environments so that you can literally get immersed and visit those sites. And through those technologies, to provide information, have a virtual tour of the site, like you would go into, like you would have a virtual tour to the museum. You have a virtual tour to the underwater site, and you have a lot of information like interest points that give you annotation and have some kind of interpretation and models that actually explain what somebody would see on that site. And at the same time, there are also now there's a lot of research projects that are working on augmented reality applications, both for divers who physically access the sites and can have a tablet device, for example, that has geolocation and provides information about the physical experience, but also have applications for people that are above the surface and visit a place and the history of the place, including the underwater site, comes alive in front of the eyes and on the screen using, again, augmented reality applications. All of the data that come out of the mapping technologies that we talked about end up in digital repositories, whether that is institutional or national or preferably international, so that there is a sharing of this data with the rest of the world and the rest of the academic community. And of course, as I said, if you have the data from the underwater cultural heritage site, you can deliver them in a specific way using virtual technology to a lot of people, not just the academia and the rest of the archaeologists. You can create immersive experiences that exploit the results of this mapping endeavor, of course, after it's being edited and processed by the archaeologists and museologists and people who are experts in delivering cultural products. And this is, for example, something that can get really interesting. Imagine if you can get the information from an underwater site and feed it into the process of creating a virtual environment that also has gamification factors inside, and thus is reaching a wider audience. And in the end of the day, there's also the part of the intangible maritime cultural heritage that comes on a parallel way and is being merged with the material cultural data that come out from the mapping technologies. And then you can deliver a more holistic approach of underwater cultural heritage again, to the public, since we're talking about the creation of this kind of interaction. And I will conclude with a small SWOT analysis of those. Uh, so technological handout that we have now in underwater archaeology, of course, it is something that um, facilitates the communication of the user with the archaeological archive, whether that is the scientist itself or the general public. So you have a lot um, in, uh, of ways of interacting with the data, and of course you can have a lot different types of files. You have the opportunity to create visualization models about the site itself, not just about what it is there, but what could be there as well. And the fact that we have nowadays databases and geographical information systems that you can build on top of the data that have been gathered so far, and you can actually add to that, means that you can add to that as an archaeologist for archaeology, but also that you can start and bringing together more disciplines in order to create an interdisciplinary approach. For example, having the 3D model for archaeological site means that you can share it with a biologist and they can use it in order to study the environment, the natural environment that interacts with the site itself, and so on. So a lot of things that can happen using this kind of technology. And it is really important because, as I said, in most cases, this kind of technology is really expensive and sophisticated and not very easy to use. So if you have joint projects, you can use the same technology to look both for geological structures, for example, and archaeological sites at the same time. This has happened in the past in Greece as well, and other countries. So there were a lot of joint endeavors of different scientists using the same kind of expensive equipment in order to get what is interesting for them in this case. And of course, if you look outside the academic community, the technological innovations that are being used in order to map this special archive are being used, as I said earlier, in the creation of interesting education and entertainment environments in order to get people closer to underwater cultural heritage, which is really important because physical access in the majority of the cases, in the vast majority of the cases, is not possible due to the hostile underwater environment. So if you can extract information from the sites and you can deliver it in an interesting and scientifically accurate way, then you help in getting people to know about underwater archaeology and underwater cultural heritage in general. Of course, when it comes to threats, there are the ubiquitous tech-related problems. Nothing is easy most of the times when you're trying to build something, but after a while, things are getting better and things are more easy to use. And this is just a procedure that you cannot avoid. But in the end, all this technology needs to, at some point, be easy to use because archaeologists, although we should not be illiterate when it comes to technology. This is not, we're not engineers. So in the end of the day, we need either someone who can work closely with us, or a software that has a friendly UI and helps us do our job. And in the brackets, I also have the term citizen science, which is something that nowadays is a trend. We talk more and more about public archaeology and how we can get citizens get engaged and aware, although there should be some limitations because they're not actual archaeologists, they're not actual scientists. But in the end of the day, there are projects that are going on nowadays trying to retrieve data from, for example, from recreational divers that can be used in the larger scheme of mapping underwater cultural heritage. And of course, something that I always have to remind myself, because I get immersed in this um, new stuff and new toys and new methodologies, and it always excites me. It's that in the end of the day, technology is the tool that helps us understand the past. So, talking as an archaeologist, I always have to remind myself again that I'm not an engineer. I'm trying to understand the past, and all of those technological wonders that I get my hands on are tools in order for me to understand what's going on. I hope I didn't bore you, and I hope I didn't excess my time limit. So I'm gonna stop sharing my screen, and hopefully there will be a discussion, and I'm ready to hear questions and comments. Thank you.
No, we thank you, Alexis. The burden of the presenter is always, to try to find questions and to see if the person who presents, may cover some subject or anything, but you were unbelievable. I mean, it was a holistic approach of the whole thing. You covered everything. It was
Thank
really
you.
amazing. And you know what struck me is the fact that sometimes in our mind we have, let's say, maritime archaeology, call it nautical archaeology, I don't know, is this, people, divers going underwater, and the fact that you emphasize the different aspects of the process, not only, and I don't mean only about the mapping, which is the main theme of, our lectures, but the fact that it's something more than Jacques-Yves Cousteau diving to find a shipwreck, but it's also, environments in the inland, like the lake environments, and or the which is actually amazing, the fact that we can restore lost nautical traditions and ship making and all this stuff. Yeah, it was amazing. So hopefully there are questions. There is one in Q&A, which I will transfer it to you. It's from Taher Morad, if I'm saying the name right. She is asking that if an underwater archaeological site is discovered legally, can the site be registered in your name until you conduct a study of the location? Do you know how to answer that?
Well, so there's not one answer to that, because it depends on the place, the country, the legal framework that we're talking about. For example, I can surely tell you that in Greece, if you discover something, you are in a way obliged by the law to report this to the Department of Underwater Antiquities. There is a procedure that you can get some kind of reward for that, but you cannot register it in your name. It doesn't belong to you, because in Greece, archaeological sites and archaeological material culture actually belongs to the state and the citizens of Greece.
Yes.
So
true.
what you can do is report it, and then if you're an archaeologist and you want to study that, then you can apply for a permit for an underwater investigation of the site or its finds. In the US, things are different, and this again depends on the state. So in some states, even if you're not an archaeologist, if you're an individual, it's like finders keepers. So you find it, it's yours for some kind of managing. Even though things are changing there as well. In the UK or in Germany, again, it's something that belongs to the state, but you have some different kinds of management framework over there. I
Okay.
hope I
Okay.
answered the question.
Yeah, you did actually. Yeah. Well, let's. I mean, if you have any questions, of course, you are welcome to phrase them in the Q&A or in the chat. Yanis Moussos, there, our
First one, hi, thank you for the presentation. It was very impressive, very interesting photos, very beautiful photos. Well, I actually have two questions. The first one is about the GIS data that are produced from this kind of projects. How available are they for other researchers to use them? Is there an open access policy? How broad this open access policy is?
Yeah, for instance, if I may, follow the question of Yanis. For instance, let's say reconstruct networks. So do we have access in this data that you present, say from shipwrecks? Because, the only thing I found, for instance, is like an Excel with all the shipwrecks in the Aegean. But if we had GIS data on that, it would be amazing.
Well, again, it comes down to the specific national framework that we're working in, and it also depends on the researcher. So, well, technically, we all know that you can share this data. You can have a shape file with all the shipwrecks that are known from various sources, and with different categorization, if it's something that is being studied and stuff like that, with different attributes. Again, I will answer about Greece. The only information that you can get is you can go to the archaeological maps, and I can actually send you a link. Just a minute. So you can get some information. Okay, it's only in Greek. Sorry for that. But there is the official database of the Ministry of Culture, the Archaeological Κτηματολόγιο, as we say in Greek.
Okay. Yeah.
Okay, so it's the archaeological registry, and there you can find not the actual site, but the buffer zone, the protection zone.
Okay.
Because it's like all the declarations of archaeological sites. So you can find, well, there is a point where the site roughly is, but you can understand the area that's being protected around the site. You can have a polygon and a point as well. But that's about it. That's the only thing that you can get on the public domain.
Okay.
Everything else you need to apply. You need to find an archaeologist from the ministry that is responsible for the sites, and they can give you, or if it's something that is being studied by the university, whoever has the rights to publish.
Yeah. Well,
And I suppose that
Sure.
not all data are in the Archaeological Κτηματολόγιο as well.
Well, all that is all the sites that are officially declared as archaeological sites or historical sites and stuff like that are on the archaeological registry. You can find them there. But there are a lot of sites, of course, that are not officially declared yet, at least, are not studied enough to be declared as archaeological sites. And well, hopefully sometime soon, more sites will be thoroughly studied and protected through the declaration.
Yeah, well, yeah, we do have 2 questions before, because I saw Vespina coming in to ask, but before that, we have 2 questions in the chat about the laser scanning underwater. How reliable is it right now, and how dependent is it, oh my God, I'm getting old, on water purity and floating contamination? Yeah, the first question.
So, okay, now, so laser scanner is, to start with, is something that needs to be close enough. You cannot have, so acoustics, you can be on the boat and send a beam down to, I don't know, 2 kilometers and wait for it to get back. And you can have a swath, you can actually scan the seabed using the sonar. You cannot do that with a laser scanner, at least as far as I know. I know that the one that we have been trying to use, that it needs to be close enough. So what you do, and that is why you cannot use it to scan a wide area like you do with a multi-beam. So you can have a very wide angle, set the beams at a very wide angle, and the deeper you go, the larger the area that you scan using the multi-beam. With a laser scanner, you're not, it's like using the wrong instrument for the wrong job. So if you want to use a laser scanner, you use it to get a precise and detailed model. And this happens only if you don't have a lot of water between the instrument and the artifact that you're trying to scan. I don't know how reliable it is yet. I know that it's being used for construction. I know that it's being used by engineers. I haven't used it yet for underwater archaeology, but I'm hopeful that we will have some good results in the near future, because again, it gives you a lot of precision. What it doesn't give you is attributes like color. You only have the geometry stuff. If you want color, you still need to take pictures. And that is something for archaeologists that is quite important, because you cannot interpret material if you don't have color. And that's why what we're trying to do with the Department of Rural Engineers in the Archaeological University is we're trying to create a rig that has a multi-beam, a laser scanner, and a Hasselblad camera, so that at the same time they get data from that are coordinated. So you connect them to the same IMU, and you have the same GPS signal. And because all this is, we first tried it from a boat, and then we'll try to mount it on our ROV. But at this point, we use a GPS, IMU, and the 3 components that I just mentioned, and we try to do it simultaneously so that you have the same XYZ for all 3 components, and see if we can deliver the best possible outcome, because you have the multi-beam taking like a wider area to get the data from acoustics. You have the laser scanner to get the data with the structure light, and you have the photograph. And if you combine, you get probably the best out of the 3.
Great. We have another question. Basically, there are 2 that are along the same line. The first one is for those new to the field, looking to work as divers in underwater archaeology. Are there newer technologies that you would recommend they should learn?
So if you want to work as a diver, which means like obviously you're talking about diving technologies, I would assume. So there are different diving technologies from we have moved forward from Cousteau and his aqualung. So nowadays, I would say that the most sophisticated type of diving is using closed circuit rebreathers.
He means archaeological, or she means archaeological tools.
Oh,
probably
okay.
mapping techniques. Yeah.
All right. Well, I would suggest you learn how to do photogrammetry.
Yeah.
It's quite accessible nowadays, because most of the software are like very, very friendly. You just feed in photographs and they come up with a good model. But if you want to do it like more scientifically, more specifically, and more accurate and stuff like that, you need to learn a bit about photogrammetry. And it's something that it's being done everywhere now because it's cheap. You just need some do it even with action cams.
Okay.
Because it is quite effective and it's pretty cheap.
Alexei,
not-
how difficult is all this new technology for the diving process? I mean, I guess
Oh.
must be, or it's not.
No,
I don't know. I mean,
it is.
I don't know anything. That's why I'm asking.
Okay, that's really interesting because the last few years I have been engaged in we're trying. There's a team of people, a community of people that we're trying to establish what we call scientific diving, which means that we are scientists that we use diving in order to produce results for our work, and we're trying to create a framework in order to produce those results using all the necessary safety protocols. So, because first of all, if you're underwater, you're a diver. You just need to take care of yourself and your fellow divers so that nothing bad happens to you.
Sure.
But
Yeah.
once you are able to do that, then you can do your scientific task. That you can perform your scientific task. It's not like going in a recreational dive and look around all the fishes and the plants and the rocks. You're there to do a job, and it's quite important to understand that because from personal experience, I can tell you that when you're there doing something that is intellectually challenging, you forget that you're a diver, and you shouldn't do that.
Mhm.
Because if you forget that you're a diver, that you're in a hostile environment, something bad might happen. So you need to train in such a way so that you are uh, comfortable enough to be a good diver and do your job. Whatever you do is adding on the challenge of being in a hostile environment. That's why it's very important to be very, very well trained.
Yeah, yeah. Well, we have two more questions. Yannick, if you can go up a little bit.
Yes. The first one is another philosophical one. What kind of valuable knowledge have you extracted that might help us understand the past, which can be useful for the future?
Safety,
God,
probably.
this is the question that all archaeologists should be able to answer, I guess.
Yeah, but they don't have the allure of the underwater archaeologists. The others,
Okay.
the simple peasants that they walk the fields. Yeah.
So I don't know if I can completely answer the question, what kind of valuable knowledge, because the essence of archaeology is to try to understand the past in order to understand the present and plan the future, and all those philosophical things that we tend to argue about when we're talking about what we actually do as archaeologists. Although I have the impression that the question is about something very specific, like so when somebody scans a shipwreck, it gets all those data. First of all, it is, especially if we're talking about, let's say, for historic shipwrecks, like shipwrecks from World War I and World War II. When you have a very good scan of the shipwreck and you have all its features, then you can identify, because we have historical records of the shipwrecks. So if you can get the information out of the water, you combine it with the historical sources, and then you can identify, for example, this is the Britannic. This is the ship that started, you know, the history of the ship. It started over there and it sank over there, and it had inside those people, and some of those people drowned. So I don't know how to define valuable knowledge, and I don't know how to define understand the past and be useful for the future. But I can definitely tell you that the more information that you can extract from an archaeological site, the more tools you have in order to make interpretations. What you do with those interpretations, it's another story. But again, the more scientifically accurate your interpretations are, the more data that you have, I guess.
And we have a last one asking about the LiDAR. I know it's very useful on land for big surfaces. This is actually a question I'm going to make also with high vegetation, but I have also heard about some successful testing on underwater sites of 10, 15 meters depth. I know you didn't mention it, but I would be interested to hear your opinion if you have any experience. Thank you again. And actually, while you were speaking, I checked that there is a company somewhere that supposedly offers, you know, underwater LiDAR services. But yeah, we expect your comment.
Yeah. Okay, so I intentionally talked about structured light instead of LiDAR, because this is what my experience is limited to. I don't have the necessary data to actually comment on this LiDAR technology. I haven't used it. I haven't been close to somebody who actually used it for underwater purposes. So I try to avoid talking about it, but I know it's out there. Although I'm tempted, I will not comment on how effective it is. If it becomes as effective as LiDAR on land, then we're talking about a breakthrough. Yes.
Yeah. Yeah, it's true.
I don't know if I'm just saying that I don't have the necessary data to say if it works or not yet.
Yeah, it's actually it's a good question, and we can you know, maybe next year we can do some more on that. Yeah,
I'm just gonna tell you, because we did a little research when we had this opportunity to use the structure light scanner, and so far we I as far as I know, it hasn't been I don't know, as sufficient as it might be in the future.
Yeah, yet of course, because
yeah,
I think,
course, yeah. It's something that will. There are the restriction of the underwater environment are many, and that is why technology for underwater research is so rapidly progressing, because there's also always a challenge, and without overstepping this threshold, this if you don't overcome this impediment, you cannot work. It's not like on land that you can use something else or you can go around the problem. Most of the times when you work underwater, it's the problem and you have to go through some way. You cannot find deviations, and you're gonna have detours.
So this basically answers the previous question about what viable knowledge you've extracted. Is exactly
okay,
that.
Yeah. Yeah,
so,
when it comes to technology, that's for sure.
Despina, you wanted to ask something, but it was this row of questions.
No. I think I was very fascinated from the lecture. Thank you so much, Alexis. It was really fascinating. I learned a lot because I'm not really familiar with maritime archaeology, and very educating, I think, for all of us here who are not familiar with the topic. Most of my questions were actually discussed already, but what I would like to ask is that do you see the application of fair principles in the works done also in the data, in the archaeological data from maritime excavations? This is question one. And my next question is that is there any collaboration or relation between the and I refer to Greek and Aegean in particular, to the underwater sites and the coastal sites, that they are in reality they are related. I mean, the harbors and the shipwrecks or something like that.
Okay, so about the first question about the fair use of data. I don't think there is a distinction between the use of data from underwater sites with terrestrial sites. So we're all living under the same archaeological framework. We all use within this archaeological framework, and we are all limited by the scientific by ethics and the ontology and stuff like that. And at the end of the day, there's always somebody who would go against that or will be limited by that. So I don't think there's a difference between the two. Although there are.
I was hoping you were doing better. Let's put it that
Yeah,
way.
yeah. So yeah, I would hope to do that too, but for that to be the case too. So the thing is that all those tools that we're using for underwater archaeology, the remote sensing stuff and all the technologies, are not being developed for underwater archaeology. They're obviously being developed for the energy companies and all those expeditions that are looking for resources and stuff like that. What we do is we take this technology and try and tweak it just to make it accessible to our need. So at the end of the day, not the big bucks are not about archaeology. So they do not affect so much what's being done in archaeology. It's mostly being affected by the general archaeological framework. So about the second question, well, definitely my approach, as you probably understand from my presentation, is that all of those sites are part of the same maritime cultural landscape. And I am, let's say, an ambassador in Greece of this kind of thinking. I try to, in any case, emphasize the fact that we're talking about a cognitive landscape. We're talking about a common way of thinking when we talk about the harbors and the shipwrecks, because my approach comes from archaeological theory and not from traditional history of art archaeology theory. So in the end of the day, we're looking for people, we're looking for patterns in human behavior, we're looking for technological aspects, and that is something that is not limited to one place or one type of sites. So these sites are inherently connected. You cannot understand one without understanding the other. And that's why I wouldn't have it any other way. I wouldn't like it to be different. I don't believe that there are experts in shipwrecks and experts in harbors. Although there are people who know more about shipwrecks and know more about harbors, archaeologists or maritime archaeologists are people that are looking into the maritime cultural landscape.
This actually is a very good pass, because this is the whole, how can I say, the whole concept behind us, making this GIS lab and this series of lectures is exactly this. We don't believe in digital archaeologists or I don't know, post-processual archaeologists and processual. We believe in archaeologists and the different tools they have in order to interpret the past. So
real
yes,
persons archaeologists who
Yeah.
use different types of tools. Okay.
exactly. Yeah.
So we are not digital archaeologists.
Yes, true. I mean,
Yeah.
I also don't believe it. I mean, we are archaeologists. We use digital tools in order to create or to reconstruct antiquity. So
That
yeah.
is that's why I had this last slide. The tool should not be the purpose.
Exactly.
We should
Yeah.
not forget what we're trying to do as an archaeologist. We use tools, different type of tools, even that is a theory or that is a skill or that is an actual tool. But in the end of the day, we're all trying to understand the past.
Yeah. Yeah. Well, how many people understand that? Of course, it's another question, another discussion, but it's not at the moment to analyze that. So if there are no more questions, and I don't see anyone, and of course, people who are here after 2 hours. Yeah, thank you very much. Despina, have any comment to make for next year?
Yes, first of all, I would like to thank again,
Of course, yeah. Yes.
Alexis. It was really, really great, and we were really glad to have you in our series of lectures and to have the concluding one. It was very useful, I think, for everybody. We learned a lot. And this ends actually the lectures of the first year's lecture series. And we plan to have another one starting from fall. So we thank everybody for attending and participating, the speakers, the audience, and we look forward to see you all again in the next series, lectures from autumn. Have a nice evening.
Yeah, have a nice evening. Everything will be on our website, in our social media. And so any announcements will be, you can find them there. Alexi, thank you very much. And let's hope we'll meet soon in person again.
And Alexi, we hope for a real collaboration because us, the terrestrial archaeologists, and you, the maritime archaeologists. Okay.
Sure.
Okay.
Thank you.
Thank you very much. Thank you.